Jeff Berardelli is WFLA News Channel 8's chief meteorologist and climate specialist. Jeff is an incredible climate communicator, connecting the dots for the audience between the extreme weather events that are happening, every day, it seems like, and the warming planet. Jeff, welcome back to the Climate Pod.
Yeah, I'm glad to be here. Thanks for inviting me.
Well, it seems like we've been inundated lately with climate news, but one thing that really stood out to me over the last couple of weeks was the spike in ocean surface temperatures. Before we get into what caused it, what did scientists observe with global ocean surface temperatures?
Yeah, it's pretty astonishing what we're seeing, and I think there are a lot of scientists who are in disbelief. I will say that. I think even scientists with the most experience who study this kind of stuff, they expected it, but it's still, and it's not surprising, but it's still remarkable to see, because ocean temperatures are not just record hot, but they're way above record hot, just way above record heat. The departures from records make this occurrence globally probably almost a once in a million type of event without human caused climate change, right? So if this would have happened 100 years ago. And in the North Atlantic, at least in the tens of thousands type of event, one in the tens of, if not hundreds of thousands type event, because actual North Atlantic ocean temperatures are about 1 degree Fahrenheit above normal. The whole ocean on average is 1 degree Fahrenheit above, not normal, above records, not above normal. 3 to 5 degrees above normal in the main development region. So it's pretty crazy.
Yeah, I mean, the visualization, that graph that has been floating around social media over the last couple of weeks, where you see that 2023 line, it does start out higher than average. When I say line, the measurement of the ocean temperature, but then it just like shoots up,
Spikes up,
beyond.
Yeah.
I mean, it's crazy,
Yeah.
and I know that Twitter isn't real life, but when this graph was first circulated, and still today, I see a ton of people commenting about this being evidence that we've passed a tipping point, meant that the climate models were wrong and we're already beyond the worst case scenarios, a lot of climate doomerism. What did you make of the reactions to this graph?
Well, first let's address whether or not we've reached a tipping point. And the answer to that is we can't be sure, right? But tipping points don't happen overnight. They don't happen in weeks. They really don't even happen in months. It happens over the course of time. So you think of tipping point, you think you're going to fall off a cliff. That's not exactly what we mean by tipping point in the climate system. Although a tipping point is a point at which you push things so far that they become irreversible and things start to snowball. But it doesn't necessarily cause a spike like that straight up in temperature. So it's likely a lot of things going on at the exact same time, compounding on top of each other. If you've looked at any kind of climate science lately, a lot of scientists are examining this compounding effect in terms of not just extreme weather, but in terms of all other kinds of things related to climate change. So is it a tipping point? Well, could we have passed one? Sure, we could have passed one. But the tipping point itself, if we had passed one, wouldn't have caused that direct uptick in temperatures. But I mean, it shows us what the potential is, right? Even if it's not a tipping point, even if doomers are going crazy and it's not really directly related to something that we didn't expect in the climate system, which it probably isn't something that we didn't expect in the climate system. But the point is made, right? That we can expect the unexpected now. We can expect things to happen that below our minds, even though we study this day in and day out, and there are thousands and thousands of papers that are published on this kind of thing. So that's how I would kind of quantify it, put it into perspective.
And you did a fantastic job of summarizing exactly what is causing this. And then it's really important to get that information out there so people have a good sense of what's happening. So I would like to just talk about some of the factors that are at play here in causing this. I want to start with the big one, El Nino. We've heard a lot about El Nino this year. What does it mean that El Nino is back, and why does that matter?
Right. So we typically see the warmest temperatures on Earth during the strongest El Ninos. So most of the record-breaking temperatures that we saw happen back in the 2016 El Nino. That was the strongest, one of the strongest on records. We saw a strong one in 82, 83. We saw another strong one in 1997. Now, the last few years, we've been in La Nina. So La Nina is a cooling of the tropical equatorial Pacific Ocean waters. And that cooling means that less heat is actually being fluxed into the atmosphere from the oceans. That's been 3 years, triple dip, La Nina. And so during that whole time, the ocean's been storing up a bunch of heat. It's kind of like a bunch of TNT, just like you taking a warehouse and just stuffing it with TNT. And every day you put more in. And then at one point, it's just ready to explode. Well, when La Nina let up and El Nino took over, which is a warming of the equatorial Pacific Ocean, all that heat now is in contact with the surface of the ocean and in contact with the atmosphere. And so there's a lot more of a flux going into the atmosphere. And once that starts happening, you're adding so much energy to that system, that interface between the ocean and atmosphere. Now releasing all that energy into the atmosphere, you're changing wind patterns, not just regionally, but globally, including the Atlantic Ocean. Let me just explain one more time kind of what La Nina and El Nino is. So essentially we have trade winds. So winds that blow from the Eastern Pacific towards the Western Pacific. And you might think about it as simply as this. Those trade winds are strong enough that they pile warm water up on the western side of the Pacific, literally pile it. Literally, you could measure a mound of water physically that's higher in the Western Pacific than in the Eastern Pacific Ocean. But when those trade winds slacken off, and it's a combination of dynamics that causes them to slacken, that causes the ocean to kind of start working in the opposite direction. It's all interrelated, right? Chicken and egg kind of thing. Chicken, egg, we don't know, but it all happens simultaneously. And when the trades weaken and there's nothing pushing that warm water up into a mound in the Western Pacific, that kind of rolls back downhill and spreads across the Pacific Ocean and then spreads all that warm water into the Eastern Pacific. And then it starts to interact with the atmosphere. And voila, you end up with some extreme weather and extreme ocean conditions too.
And are those trade winds or the weakened trade winds, is that what's causing the lack of Saharan dust to be in the atmosphere above the oceans?
It's a great question. So I was speaking of Pacific trade winds, not Atlantic trade winds, but you are correct. We have seen a slackening of the Atlantic trade winds to some degree, partly due to a weaker high, what they call an Azores high, but it's really a high that kind of steers tropical systems on its southern side. It's this semi-permanent feature during, tropical cyclone season, during hurricane season in the Atlantic Ocean. That is really weak. And when that weakens, the wind flow around it weakens, pressure gradients weaken. And yes, as a result of that, you're going to be kind of scouring a little bit less sand off of the Saharan desert and thus less dust into the atmosphere. You have less dust, you have less particles to obscure the sun, more sun gets through, it heats the blue ocean. We hear about blue ocean events. It heats the blue ocean and it warms it up even more. So there is an aspect to what's happening in the tropical Atlantic that is due to this weakening high, weaker trade winds, less Saharan dust. So there are natural components. It's not just climate change, but of course, we know that climate change is a significant part of it now.
One of the more bizarre conversations that I saw around this graph, the spike in ocean temperatures, was people calling for the shipping industry to put sulfur back into their fuel to make it dirty again. I'm thinking, what in the world are they talking about? How does less polluted shipping fuel cause these ocean temperatures to rise? Right.
So that's a part of it, right? So any kind of pollution that we emit into the atmosphere, be it from ships, and there was a law passed in 2020. So we've seen an 85% dip in the amount of sulfur dioxide that's been pushed into the atmosphere over the last 2 years. So that has some effect. Scientists trying to quantify it. Some say it's less than 1/10 of a degree, but there are other people who surmise it may be more. James Hansen, actually, Dr. James Hansen, the famous James Hansen, thinks that it may be more significant. But if we're going to talk about aerosols and pollution, we need to look back much further than that. The Clean Air Act was passed in the 1970s, and that really cleaned up our act in the United States. Now, our prevailing winds in the Northern Hemisphere where we're located blow from west to east, and so that takes the pollution into the Atlantic Ocean. More pollution over the skies of the Atlantic would obscure some of the sun and actually cool the oceans. So this reduction in aerosols is not just the last couple of years due to sulfur dioxide from ships. It's also a progression over the past few decades. And the Atlantic has indeed warmed. Some of it is indeed due to the reduction in aerosols and pollution, and some of it is greenhouse warming. But in general, the oceans as a whole globally have warmed around 2 degrees Fahrenheit. And that's true of the Atlantic Ocean as well. And that what we've seen, and I'll just be quick about this, is we've seen an uptick in Atlantic hurricane activity since the 1980s, so starting in the 1990s. That could be due to a natural oscillation that we call the AMO. It could be due to greenhouse gases and the warming due to that. And it could also be due to the reduction in aerosols. And a lot of studies are finding it may be almost a greater proportion aerosol reduction in the North Atlantic. So, but it's probably all those things, right? It's not, it usually is all those things, or at least a couple. It's not usually one smoking gun, if you will. So getting back to your question at the outset, yes, if we were to start spewing more pollution into the atmosphere, we would cool the atmosphere. And there are a lot of people who want to geoengineer climate change to try to use that, shooting particles into the stratosphere, obscuring the sun and cooling us down artificially by a degree or so. We don't know what the repercussions of that would be. It could be very dangerous. We could be playing God, if you will. But one thing I should say, and you know this because you study this and you talk about it a lot, Ty, is that air pollution causes 8 to 9 million deaths per year around the world. So we might solve one problem and we may make another problem even worse.
Oh, yes. And just so it's on the record, I am definitely not a proponent of adding sulfur dioxide back to shipping emissions. That's for sure. Just one other, there was another factor as I read through your summary of what could be contributing to these warmer ocean temperatures. Another factor jumped out to me that was pretty surprising. The fact that last January, an underwater volcano erupted in Tonga.
Mm-hmm. Yeah.
And scientists are saying that this is actually causing global temperatures to rise. I thought that volcano ash caused temperatures to decrease. Why is this one different?
Well, of course, you're asking the right questions, but I know you already know the answer to this, but it's okay because the viewers may not and the listeners may not. So Hunga Tonga, when it erupted, it was under the water. It's not an overland volcano. It's underneath the water. So instead of spewing dust into the atmosphere, it spewed tons and tons of water vapor directly up into the stratosphere, where it still is. So we have all this residual extra, water vapor, H2O, sitting in the stratosphere, and it's a greenhouse gas. Water vapor is a greenhouse gas. In fact, it's a stronger greenhouse gas than carbon dioxide. So when you put all this water vapor into the atmosphere, you end up spiking temperatures as well. So remember, it's not just one thing, right? Climate change is a big part of it. Greenhouse forcing is over the longer term going to be the biggest force that dictates our future. There's no doubt about it. But there are a lot of layers to this layered cake. And it just so happens that everything is layering on top of each other at the same time. We don't know how to quantify each discrete part of it yet. Somebody could do a study on it. A couple of people could do a study and try to figure out, okay, what portion is the Clean Air Act? What portion is SO2 from ships? What portion is greenhouse forcing? What portion is, the reduction of Saharan dust and the lessening of the trade winds? And what portion is the Hunga Tonga volcano? We don't know what portion is which. A lot of the craziness that's going to go on this year is going to be due to the switch between La Nina and El Nino. Natural variation is still a somewhat stronger force than climate change, but climate change is getting stronger. It's more powerful. It's at the gym all the time, lifting weights, and pretty soon it will start dictating and actually being, in some cases, more influential than even natural subseasonal patterns. I don't think it's going to happen in the next decade or two, but sometime, we just keep letting climate change loose, if you will, it is going to start dictating weather patterns. It's not doing that right now. The way I like to look at it is climate change is piggybacking on the prevailing natural pattern. So if a certain pattern is going to evolve, it's still going to evolve. If nature wants a certain pattern with a strong jet stream or a weak jet stream to evolve during one particular winter, it's still going to happen based on natural variability and oscillations. But climate change is going to piggyback on it. It's going to add more energy, and therefore it's going to bolster whatever pattern is actually, in most cases at least, whatever pattern is prevailing in that particular season. At some point in the future, climate change may be able to interfere and kind of stop the natural flux of things and start taking over. But right now, I look at it as very much kind of like weather patterns on steroids. Climate change, greenhouse forcing being the steroids.
Right. So shifting slightly away from the ocean warming conversation, but back to one of its causes. You talked about El Nino earlier. Um, are some El Ninos stronger than others? And if so, do we know what kind of El Nino we're seeing in 2023?
Yeah, some El Ninos are weak, some El Ninos are strong. The definition of El Nino is a couple things. One of the hard and fast definitions is that the water temperature in the equatorial Pacific Ocean in the what we call Nino 3.4 region has to be 0.5 degrees Celsius above normal. Okay, that's it. That's the hard and fast criteria. After that, there needs to be some talking or interface at the ocean atmosphere interface, meaning there has to be some connection between the oceans and the atmosphere, that the oceans, there's evidence the oceans are forcing the atmosphere at that point, and they're talking and communicating and interacting. And once that starts happening, where we start seeing changes in weather patterns due to the underlying water temperatures, we know that it's a coupled system, and thus El Nino has been born. Yes, there's been some really strong ones, 82, 83. In fact, at the Galapagos Islands, we end up with tremendously warm water, sometimes 10 degrees Fahrenheit or more above normal. And that unfortunately depletes a lot of the nutrients from the water, and a lot of the fish and marine life that normally live there will leave. Well, the penguins can't really go anywhere, the Galapagos penguins. So during the 82, 83 El Nino, and then during the 97, during the 82, 83, something like 80 to 85% of the Galapagos penguins died because they were starved. They couldn't find food. This is these meaningful impacts here. And then in 97 El Nino, something like another 65% of what was remaining died. So it takes its toll. These are natural oscillations. However, they can be spiked by El Nino and La Nina. What we don't know yet is exactly what the impact will be. There's been a lot of research on El Nino and how climate change may impact it. It's been back and forth, back and forth. There seems to be a little bit more consensus over the past few years that it's likely that climate change may make both El Ninos and La Ninas stronger. So there's certain episodes that will end up being stronger than they otherwise would have. But there's not necessarily evidence, I think, that there'll be less of them, or that there'll be more of them. It's just the intensity of them, which kind of goes hand in hand with everything that we say about climate change. Climate change makes the extremes worse. So in answer to your question, yes, some can be stronger, some can be weaker. This one right now, odds are it's going to be a strong one, or at least a borderline moderate strong one. And there's some chance it will be a super El Nino, meaning that water temperatures will be somewhere around 1.5 degrees Celsius above normal in that particular zone.
So what could that mean for extreme weather for the rest of 2023?
The more energy you put into the atmosphere, the more extremes you get. We're going to see extremes that we have never, ever experienced in the history of modern man and woman on this earth. There's no doubt in my mind. That's not even conjecture or a guess, because our base temperatures are the highest they've ever been because of climate change. Climate change is that foundation, the baseline, which keeps rising and rising. And then put a super El Nino or a strong El Nino on top of that. Now you're reaching heights you've never reached before. And we're seeing that with the oceans right now. So what we're seeing right now, even though it's not just forced by greenhouse gases and by global warming and climate change, whatever you want to call it, what we're seeing right now is evidence of just how high the potential can be, how far we can force the climate system out of the bounds that we've ever traditionally seen.
I mean, and that's happening right now. Today, there's a heat wave that's hitting Mexico and Texas right now. It's off the charts.
Yes.
How unlikely are the temperatures in Houston right now, given that it's still June?
It's very rare. I can't evaluate it on the surface. I can evaluate it in the mid-levels. So we call it like 500 millibars. But looking at the 500 millibar ridge, which is what we call a heat dome, when you see us say heat dome is what we mean. The sigma is somewhere around 4, a little bit more than 4 sigma. So what are the chances of a 4 sigma event? Well, 0.00 whatever. So the chances are somewhat like 1 in tens, if not hundreds of thousands. Meaning the historical statistical chances of a heat wave that's occurring in Mexico right now to occur without climate change, without human-caused warming, would be 1 in 100,000, or possibly even more. The numbers become they change very quickly when you get to such high sigma or standard deviations from the mean. The bottom line is it's basically impossible without climate change. That's the bottom line. The strength of the heat dome. Surface temperatures, I would have to evaluate separately.
And we're seeing other anomalies happening weather-wise, and we're seeing right now potentially a hurricane coming out of the Atlantic. Again, it's June 20th. This is unlikely.
Yep.
Is this being caused? Is this a result of El Nino? Is this a result of climate change? Both?
Well, what's happening in the Atlantic shouldn't be a result of El Nino. El Nino usually works to kind of bat down, and destroy hurricanes, although usually that's a little closer to the US, not so far out in what we call the main development region. So this is the development out there has likely little due to El Nino, but water temperatures are 3 to 5 degrees above normal in the main development region and far above records, and actually normal for peak hurricane season in September, so 2 months ahead of time. So that's what's one of the contributing factors. And also we talked about the other contributing factors: less Saharan dust, less dry air, and a better, more conducive atmosphere to kind of incubate these storms. So we'll probably end up seeing more and more of that in the future as we continue to warm the oceans, even at times when the natural variability in the Atlantic is such that it should be cooling down, and it will cool down, but the baseline will be so much higher that it'll only cool to normal. It won't cool to 2 degrees below normal. Get it?
Another climate and weather-related event that made headlines recently was the wildfire smoke that hit New York City and other northeastern cities. A lot was made by how unprepared local officials were for such extremely bad air quality conditions, and some pointed to the difference between what was forecasted and how bad the smoke and air quality actually were as part of the problem. For meteorologists, how hard is it to forecast the direction and the intensity of wildfire smoke?
Well, that's decently easy for us. We have computer models that tell us, based on the prevailing winds, where that smoke is going to go. So we can tell you within a day or two where it's going to go. But remember, some of these events are unprecedented, at least in modern times, or at least in the past several decades. So no one remembers the last time it was that bad. And so meteorologists can stare at a screen and say, oh, that smoke's coming at us. But until you're actually in a sky that looks like New York City looked like a week or two ago, you can't believe it. You would never believe it could happen, even if you have the scientific training. So we're starting to see these unprecedented things that, although we kind of know they're going to happen, it's still shocking when they do happen. What I would say about the Canadian fires is, this year it's not California. Why is it not California? Because it rained like crazy over the winter and snowed like crazy out there. So at least for right now, we're okay. But Canada's been under a heat dome for the past, several months. Temperatures have been very warm. It's been very dry, especially in Western and Central Canada. And we're seeing those patterns develop, not always over Canada, though, sometimes over Siberia. They're always somewhere in the late spring and early summer, these big blocking highs that kind of intensify and dry out the ground and make it hot. And so when someone lights a match or lightning strikes, all you need is an ignition, and now all of a sudden these fires burn out of control. So just because it's not happening in the same place every year doesn't mean anything. It's not going to, right? The weather's still going to shift from place to place, but we start to see these bigger, larger scale type heat domes that set up in high latitudes and are burning forests that are pristine. These forests, it's just millions and millions of acres of forest, and there's nothing to stop them. There's no way to fight these fires. Often Canada is off to its worst fire season ever. Again, it may not be Canada next year. Maybe it'll be Siberia next time. Maybe it'll be Alaska next time. Maybe it'll be back in the Pacific Northwest and California. But each and every year, we're seeing this happen somewhere or multiple wheres.
And we know that human-caused climate change is contributing to the intensity of those wildfires. We know that the Earth has warmed drastically in such a short amount of time, basically since the Industrial Revolution, as a result of human influence, burning fossil fuels. A fantastic visualization of that warming are the climate stripes created by Dr. Ed Hawkins. We had Dr. Hawkins on the show a couple years ago, talk about the IPCC report as well as the climate stripes. What I just found out today, right before we got on the show, was your role in popularizing the climate stripe. So I'd love to for you to just tell the audience that story.
Sure. Back in 2018, I was a meteorologist in Florida at the time. I'm back in Florida again. And I was kind of plotting my next move. And I realized that there was this huge need to get climate change into the national media. So I started kind of working on that back in the middle, 2015, 16, 17 range. And in 2018, I happened to be looking for a simple way to communicate climate change to the masses. I just felt like if we had some tools to kind of help communicate, it would really help to educate people. And I came across Ed's stripes and I said, wow, this would look great as a tie. If you've ever seen the pattern, it's like a striped tie. And I said, wouldn't it be cool if I got meteorologists all over the world to don ties or pocket squares? You can kind of see, this is it right here. And try to spread awareness on climate change. And so we got hundreds of meteorologists from all over the world to do it that first year. We called it Met Unite. And that kind of metastasized into Show Your Stripes, where myself, Ed, and Bernadette Woods-Plackey from Climate Central helped to organize it. But remember, Ed deserves all the credit for this visual. I had nothing to do with the visual, just simply organized the event and popularized its use in clothing just to kind of get it out there. And since then, it's taken on a life of its own. I mean, the Pope actually was presented with climate stripes about a week and a half ago. It's been used as logos for the WMO, World Meteorological Organization, the AMS, the American Meteorological Society, the UN in some respects, which is the parent of the WMO. Even the US House of Representatives Climate Committee was using it as their logo. And I can go on and on. Greta used it as the cover of her book. So it really has become the international symbol of climate change.
And this interview is being published on June 21st, which is International Show Your Stripes Day. So if you're listening to this, show your stripes. Post a picture on social media for sure. Jeff, I was a fan of your forecast on the CBS morning show because you did just such a great job of explaining not just what was happening, not just the weather event, but how it was exacerbated by a warming planet. You're still doing that at WFLA and on social media. A fantastic follow. Truly, I mean, your breakdown of what happened on the ocean sea temperatures was super helpful to me. And now you've recently launched your own show and a podcast called Jeff's Climate Classroom. Right. Can you just tell our audience a little about the show and how they can follow it?
Yeah, listen, it's a way for me to vent and to educate the masses on climate change. So every week we try something different. Today I interviewed Ed and we talked about, the warming stripe, Show Your Stripes Day, which is tomorrow now and the 21st of June, which is, by the way, every first day of summer is Show Your Stripes Day. And every week it's just a different subject. I did one on hurricanes and climate change. I did one on El Nino and hurricanes. I'm going to do stuff on climate solutions. So it's just going to be probably to some degree what you do. We do it on our website, WFLAnow.com. And we also do it on our WFLA Facebook page. And then we rebroadcast it when it's done, recorded onto YouTube and Apple Podcasts and Spotify. So just like everyone else, I'm just trying to do my part to educate folks on the gravity of the situation and the fact that we can actually solve it. We know what it is, what's causing it. We have the tools to solve it. We just need the willpower.
Well, we will link to that show in our show notes so our audience can check it out. I know there is a ton going on today and you're super busy, so I really appreciate your time and your ability to clearly explain what's going on. Jeff Berardelli, thank you again for joining the Climate Pod.
You're welcome.